see if I can change these. Okay, so we're looking at almost 2 centimeters here. So what we want to do is we just want to make sure that we're not getting a red node showing that we're failing because we missed a nozzle or a manway or a ladder step. So we can quickly go through each of these stations, look and make sure that it's not because the point cloud is sticking out in a strange way. These all look valid, so we click OK. And now we're ready to create our report. So I'm going to click on Create Report. I'm just going to give it a nice name. Pick a folder to save it. And then we're going to be prompted, what items do we want to include in the report? We want the verticality, we want the roundness, we want the bottom settlement, and we want that shell settlement. We want all of these in here. Now with the bottom, we have the option to do like a traditional tank inspection today, where they'll take a laser line 1 meter above the floor, and then they'll check the elevations of the floor. With scanning, we have a couple of other options. We could actually fit that horizontal plane right through the point cloud and get kind of a high-low or a cut-fill report. And we could do the same thing even if it was a cone up or a cone down. But for this, we're just going to stick with the traditional for now. We can set a tolerance for our verticality. So let's keep it at that 1.9 centimeters. Maybe we'll just make it an even 2 so we don't look insane. Then on our roundness, we can set criteria as well. For roundness, we can set a tolerance for an upper part of the tank and the lower. So because we know that the bottom of the tank should stay put, so if we look at our tank like this, we may hold the bottom of the tank to a higher criteria, higher tolerance setting than we do the upper part of the tank. So that's why you see 2 sections here for the setting a height above shell to bottom weld. So we could just set something like 30 centimeters. And then we can set a tolerance for the top part and a tighter tolerance for the bottom part. The shell settlement, these are some kind of metrology, steel properties, numbers. I'm not good at explaining these. The numbers are good so far, but if people want to change them to something else, they could. Then you just pick what units you want your report to be in. So in the US, most people are using inches. The rest of the world, probably centimeters, I would guess. Now you can have the point cloud displayed in the graph and the report or not. I'll just choose not to have it. And then click Create. So it's very quick to create this report. And then it's going to create it in an RTF, a rich text file format that we can look at inside of Microsoft Word. That allows us to make changes. Whoa, I don't know what I just did there. Okay. And at the beginning of the report, we have general information. Almost every tank inspection company will have a section like this at the beginning of the report, telling some general information about the tank, the size, the height, how we did our stations. There were 8 of them. We went clockwise. The tolerance settings that we set for the pass or fail criteria. And then you'll scroll down and start to see the verticality report. So you'll see a black line representing true vertical. You'll see these vertical green lines representing our tolerances. And then these blue line is exaggerated, showing the shape of the tank. Now, if we had the point cloud displayed, you'd see kind of a fuzzy points around this line as well. Each increment here you can see is 1/2 centimeter, these kind of gray or dotted lines going out. So you can see the amount of deviation on here. So you'll see station 1 on one side of the tank and the corresponding station directly across from a station 5 on the other side. Then if we scroll down, again, those were exaggerated. You can see the exaggeration value. The software picks what it thinks is best. We'll see the same information, but in a table form. So remember, we have the courses going up the tank, course 1, 2, 3, 4, etc. Then we'll see the height of the measurement that was taken. We'll see the elevation as well. And then we'll see the tolerances we set, how much deviation there really was, and whether it passed or failed. So this first one was actually pretty bad. Now this is important. These are all in table form. So I could copy these and paste them right into a spreadsheet like Excel. Now this is important because most of these tank companies have already created spreadsheets. A lot of them will tell you they have their own programs they've developed. Most of them have made something in Excel. So being able to copy these values out and put them into a spreadsheet is really valuable to a lot of these companies because they already know how their spreadsheet works and they have it set up the way they want. So they love our report, but they really love the fact that they can just copy information out of it. So as we go down, we'll go through each of our 8 stations. So here's the last 2, 4, and the corresponding 8 across from it. Again, you can see there's some deviation out here. And if we scroll down, we'll see that deviation in our table form as well. Next, we'll get into the roundness. So very similar, we'll have a black line circle representing the round, a true circle. We'll have our green lines representing our tolerances for pass or fail. And then we'll have the blue line representing what's going on. And if you scroll down, you'll see the same information. Now this is at a certain height on the tank, and it's showing you what's going on at each of those 8 inspection stations. And again, table form, so we can copy and paste it right into a spreadsheet if we want. Now there's going to be a lot of these because there's all of these, remember those yellow lines going up the outside of the tank. If I look in here, on my grid, all of those, oh, that's not the one I wanted to show. Measurements. So each of these yellow lines, horizontal lines, we're going to have a graph showing that. So I'm going to quickly scroll past there because they all look pretty much the same. Oh, and then we get to our bottom measurements. So on the bottom, we have the outer zone that we talked about. These are the elevations starting at the shell going towards the inside. Then we get to the inner measurement. So that's at that zone that I set, and then continuing. So you're only going to have a few of them going towards the inside. So these are the elevations. Then we have that also in a graph form. So you can see what it's doing. Here's that arbitrary line we set up above. And then down here, we have the information in a table form. So we'll have 8 of these as we go around. So you can see exactly, remember we had more inspections on the outside and then just a few nodes on the inside. And then we'll get down here to the shell settlement report. Again, I'm not great at explaining this. This is a fairly detailed information, but when you show the inspection customer, they'll generally know what's going on looking at this report. Okay, so that is the gist of the inspection. Again, we've got videos on the secondary containment and on the volumes on YouTube. On partner site, we also have this exact same data set loaded up under the real work section under sales and marketing materials. We also have presentations on there as well as videos. I'll probably be loading the PowerPoint that we just looked at on here. So assuming that my webinar is still working, I'm going to try to take a look at questions. We've got about 8 minutes left for questions. And, oh, what happened here? All right. I don't have my technician available to help me. Let me see if I can undock this. Okay, so there's a question about verticality. Is it absolute or relative to the reference for a vertical plane? I don't know the best way to answer that, but with the verticality, basically what we're doing is we're taking the verticality from the instrument. So with these scans, you want your instrument to be certainly set up plumb, have the compensator turned on if one's available to you. I prefer the TX8 over other scanners like the FARO or the TX5, just because it does have that survey grade compensator, and because we're looking at verticality pretty strictly, we like to use that. We're creating that plane right there directly, or vertical line, if you will, at that point of the inspection position. And then we're going to compare directly straight from that across to the tank, if that answers the question. All right, so we've got 5 minutes left. Any other questions? Oh, can I share the report by email? I can share the report by email. Feel free to email me individually. That would be easier. And also, I'll put a report on the partner site. I will show you here. Maybe I've got some recent reports. I'll show you one of the secondary containment reports that I recently did. So when I do these reports, what I really like to have, got all these windows getting in my way. I really like to take screenshots. So this is not the inspection report, but the secondary volume report. And it doesn't give a pass or fail. It generally gives an exceed or doesn't exceed. And when I do screenshots, I actually like to take the 3D visualization and I move it down close to my coordinate indicator. And I'll do a screenshot close by there so the customer can see which way is north. Now, when you scanned, you didn't have true north set up, in RealWorks, you can use the user coordinate system or frame creation tool to go and set that so that north is roughly in the right direction, so it looks good on your reports. People generally like to see where the manway is in relation to north. So that's why I moved this down here so my screen snap would incorporate that. Then I'll try to get a couple of shots from the side and maybe a kind of a 3D view here so everybody can see how their tank is oriented. This is what really sells the product, is these nice visuals. And unfortunately, by default, we can't, well, we probably could create some in the report, but they wouldn't look as good as the ones that you do, moving this around so that you can get the view just exactly the way you want. So these visuals really look good, even on the tank inspection. I have one, but I can't share it with you yet. It's customer personal data. But like with the SX10, on an outside scan, what I did was I took the station-based view and I had this inspection map displayed. So I had a picture of the tank from the outside with just the photos of it. And then I displayed sorry, somebody's making faces at me out the window. Then I displayed the inspection map on top of it. So very quickly, the customer was able to see the comparison between the two and know the owner operator can really relate to the photos. So adding the photos, adding these 3D views into your report are what really are going to help sell these to the service provider and, more importantly, to his customer, the owner operators. Okay, so I am running out of time here and I don't see any more questions. I do have to leave the room in about 30 seconds. So I appreciate everybody popping on here. You have my email address. If you don't, I'll add it right here. New slide. So I will certainly help as much as I can on demos. I'm helping a lot of the guys with demos now. Sometimes I'll have 4 or 5 demos in a week. But I know the terminology. I know it's difficult for you not knowing the tank market specifically. So any questions, feel free to help or ask for help, and I'll help you as much as I can. I can help with the demo. I can help give you reports with screen snaps or general questions. Again, just closing, the main emphasis, inspection is certainly our strong suit. We can do volumes and calibrations, but we're limited in our capabilities, and there are no standards for this. So people need to understand that going in. For the volume secondary containment, we actually do this very well. It's not quite as big as of a market, but when people see it, it's an excellent added deliverable that they can add. And again, adding those visuals into the report, the owner operators really respond to that. Okay, thank you everyone. My time is up. And again, you've got my email address. Any questions, feel free to contact me, and I hope everyone has a great day.